We are now going to make an example of a TETRA radio network planning. To start with a few base stations placed by the radio planner manually, and then continue with automatic planning, and end with frequency assignment to the newly created network. So let's place a TETRA base station near this town. I right-click in the map, select New Station and TX Position, and RAP makes use of predefined station templates. I will use a TETRA base with 48-meter high antenna. So the frequencies are predefined for this station. They can be changed very easily by selecting from a channel plan, but we will stay, for this case, we will stay with the selected frequency. But here the operator can select from the predefined channel plan. Transmitter data is predefined for the template. The antenna in this case is an omnidirectional antenna in the horizontal plane, and in the vertical plane the radiation pattern looks like this. So we will stay with that antenna and the configuration for that base station. So here this single base station is listed. Now we will perform a coverage calculation around it. There are several settings to the coverage predictions. Received power is the one mostly used for TETRA. I make the initial selections here, and these settings are remembered for the next times I make these calculations. So the calculation runs now, and it is ready. The result appears here in coverage results, and here it is. I right-click on it, select visible. So that's the calculated coverage for this base. The map display with all the colors is not so suitable when displaying color-coded coverage results, so I change the map display to be grayscale instead. So there we are. The colors represent different received signal levels. I calculated downlink, transmitting from the base, receiving in the mobile, and minus 106 dBm for the red color represents the sensitivity level. For some planning margin, we would need some 12 dB or so, 10 to 12 dB perhaps. So the green color represents the downlink predicted coverage. Now, it is a very quick procedure to create more base stations and perform calculations for them. So I use a command here, copy and immediate coverage. Now when I place the cursor and left click in the map, a copy of the base is placed there, and the coverage is calculated and displayed in one operation. These are single station calculations, and when presenting all of them on the map, it tends to be a bit busy. I can merge these into a single composite calculation and show that instead. Now this is the combined coverage for 3 TETRA base stations, and the green color represents a good signal with planning margin. Red color is marginal and should not be used as a planning for the planning procedure. What I showed now was doing this manually. The radio network planner selects locations, places the base stations, and performs calculations. Instead, now we will do this in an automatic way to optimize the coverage. So I'll remove the display of the coverage there, and we'll make use of the cost and coverage optimizer tool. The cost and coverage optimizer has many settings, and a quick way to get started is to load settings that have been done before. And for this example, we have prepared this TETRA wrap coverage optimizer settings file, and it will automatically place base stations within this map area in order to provide coverage against the TETRA mobile station. With a 2-meter antenna height above ground level, so this is the same TETRA mobile that we used before for the coverage calculations. The coverage area is around 4,300 square kilometer. That is our required area. Going back to the placement tab, the type of station that we are building is the same as used before, the TETRA base station, 48-meter high antenna. We have defined in forbidden terrain that it is not allowed to place the base station in water or in swamp areas because it's difficult to build the stations there. If we want to make use of existing stations that may have been very well prepared and well designed, we can check the ones to use, and they will be used together with the new optimized placements of new base stations. But in this case, we do not select because let's totally optimize the coverage and minimize the number of base stations required to achieve coverage. The cost tab defines cost items. In this case, we work with only one type of station, the new site, that is greenfield, a completely new site with power and everything to be constructed. And for the demonstration, we work with a single antenna height, so all stations will have 48-meter antenna height. This can be a list of antenna heights, and each of them with different cost. The optimization takes longer, and it is not so good for the demonstration, but it works very well and optimizes also each base station for the suitable antenna height. Costs for existing stations can be defined. Existing site, that is, if we have a list of existing antenna towers where the new antennas, the new bases are allowed to be installed, then they can be introduced into the optimization also. The evaluation tab, that is where we make settings for selection of propagation model. This is a terrain dependent model. It is the same that we used before for the terrain dependent coverage. Calculation direction, we will do uplink because in this situation it will be the uplink transmitting from the mobile, receiving in the base, that is the limiting range factor. The optimization is done for a received power of 10 dB above receiver sensitivity. So this is a planning margin in order to have a good high probability location coverage, and 10 dB is a reasonable margin for this environment. The solution will go for minimum coverage 95%. So at least 95% of the desired coverage area will be covered with a received signal that is 10 dB above receiver sensitivity. That is the optimization condition. We could do a maximum cost criterion. That is when a case when we have a fixed budget and have been meticulous about defining the cost items. Then it will come back with a response of best coverage, highest area coverage that can be achieved within that limited budget. So when I press OK, the calculation starts. And there is a progress meter here. When it has come to about 25%, it starts placing candidate base stations in many locations, good selections of potential base station placements. It shows a progress in the map. Perhaps it's a bit difficult to see. It's a black circle moving around. There it is now. And this continues until about 79% when another phase in the optimization is starting. So basically this optimizer works in a way of selecting from a list of existing sites, if we define that, existing base stations and greenfield sites, calculates many coverage plots around that and makes an optimization to minimize the number of base stations, or actually minimizing the cost for the base stations. It came up with a need for 30 base stations. The cost was not very accurately defined here, so it just says 2 for each base. If we had different antenna heights and other different criteria, different definitions for the base stations, the cost would have been variable here. The covered area is 95%, and that is exactly what the requirement was. Pressing generate stations generates the stations for further calculations and further analysis. I will use the default station type, which means that we will not change the station to create now from what was used in the optimization. Otherwise, we could introduce sectorization here, but that is not a common case in TETRA anyway, so we'll use the default types there. The list now shows the 30 base stations. I'll take away the ones we created manually and show these on the map. So there they are. The map can be changed also to take away the image map, and that is sometimes good when we really are not interested in the cartographic features. We are just interested in some coarse map like this. Okay. Now these base stations are all identical. They all use the same frequency, and they cannot do that in a real network. So the next step can be to optimize the frequency assignment for low interference. That is done by using the frequency assignment tool. And in this tool, we first make a selection of the channel plan. This is a prepared TETRA plan with 20 paired frequencies in the 390 megahertz band. And we make settings for the propagation model and so on. And now we will make the same settings as we did for the coverage optimization. We used 10 dB planning margin. Here we will limit the server range. 15 kilometer is probably reasonable because the separation between the base stations is something like that. It's on the average it is lower than 15 kilometer. And pressing OK, then we have made the settings. All these settings can be configured and remembered. And pressing calculate will then perform calculation now of all interference paths and wanted signal paths in this network of 30 base stations. So there are a lot of calculations going on now to position the mobiles at worst locations from an interference point of view within the limitations that we gave for the blocking calculations, such as maximum 15 kilometer server range. Now it is ready. And to perform the following optimization of the frequency. Now all use the same frequency, so we will remove that, remove the existing frequency on all stations, and then perform the automatic assignment. And now the assignment is ready. There was no message of warning there that some base could not be assigned, so it was a successful assignment. The chart at the bottom of the window here indicates the margin. A red color indicates that if we try to assign that frequency, there will be interference. A yellow indication, yellow color here, indicates that that frequency can be assigned and will not give interference. Blue, which may be a little difficult to see where I have the cursor now, indicates that that is the frequency in use by the station that is marked in the upper left list. So if we have a look at the details for that frequency, it has a good signal to interference condition, a low interference level. If we have a look at the adjacent frequency, it is interfered with, still positive signal to interference ratio, but TETRA requires better than 12 dB, and this means that it is not available to assign. The assignment can be done once more if we want to have two frequencies for each base. So let's assign another frequency for each base. Now it takes a little longer because it has more considerations to make, since there already are 30 frequencies, one for each base. Now it adds one more to each base, totaling 60 frequencies. Okay, then closing this window invokes this question: would you like to save your assignment? Yes, we will do that. Now these assignments are saved to the base stations. So if we click on a station now, we can see that it has an assignment. We can have a look at the way the frequency spectrum is used by using the spectrum viewer, and it shows now the calculated field strength at the cursor position where I click in the map. It can be changed to display number of stations per frequency. So for instance, at most we use 6 stations per frequency, and clicking here shows that that frequency, for instance, is used by the base stations that now are indicated in the map. So this is a very optimized network. It uses the minimum number of base stations, that means lowest cost in this case, to cover the 4,300 square kilometer of desired area, and it uses the minimum spectrum, the minimum number of frequencies that is required to fulfill the interference and quality of service criteria. This project can be saved for later use or further analysis. So I save this on hard disk, and that finishes the TETRA coverage optimization and frequency assignment.